Nasa menu rin ang weekly plans para sa grade levels na base sa Most Essential Learning Competencies o MELC. Interactive ang learning tools dahil gamified ang exams at quizzes. Wala nang excuse para bumagsak, ha? Sa panahon ngayon, hawak kamay tayo at magtulungan. Salamat sa teknolohiya, mailalapit natin ang edukasyon sa bagong henerasyon. Come on na sa DepEd Commons. Gawin nating accessible ang pag-aaral. I-follow ang Department of Education sa social media at bisitahin ang iba pa nilang websites for more information. O sige, ang dami ko nang sinabi. Kahit daliri lang ako. Paalam!
Alright, so good morning everybody. Good morning to our teachers, especially the math teachers around the country. So I am Teacher Ariel from SDO Las Piñas, an EdTech specialist, Department of Education Central Office. Alright, so before we start, may I invite everybody to pause for a moment of silence for our prayer. And later on, ipapakilala ko sa inyo ang aking napakagaling at napakaganda na co-host, and then magkakaroon tayo ng napakagandang session for our mathematics. Especially, this is hosted by or presented by Casio Calculator Philippines. Let's have our prayer before we start our session.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فقال ربكم ادعوني أستجب لكم آمين يا رب العالمين الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين اللهم اجمع شمل المسلمين والكريستيان والأمة في مدينة دباو وسلم دائما مجتمعنا هذا بالسلم والأمن والتقدم في بلدنا هذا آمين يا رب العالمين ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على خير خلقه سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين آمين يا رب العالمين.
In the name of the Father, Son, and Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you, when we forget to acknowledge your presence in the image of our brothers and sisters, and for moments we fail to be good stewards of the blessings you have given us. Continue to guide and protect each one of us, Lord, that we may always walk in the lights of your everlasting love and mercy. Grant us, Father, with your comfort in times of distress and with your strength in times of weakness. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with the prayer and the intercession of our Blessed Mother. Amen.
Manama, mawantog ka. Warag po ko iling koy ko. O Diyos, kahibulungan ka. Busa ikaw lang ang simbahon ko. Busa ikaw lang ang alagaran ko.
Ayan, so once again, welcome dito sa ating session for mathematics, our math day for all the teachers out there. So let me introduce to you. Sabi ko nga kanina, tayo ay sasamahan ng isa sa pinakamagagaling na teacher sa mathematics, one of the best teachers from SDO Malabon, at siya ay nagdiriwang ng kanyang birthday today, none other than Ma'am Reg Esquilia. Good morning, Ma'am Reg. Hello po.
Good morning, sir. Salamat sa pagbati. Ayan, good
Ayan.
morning po.
Ayan, so napakagandang araw na ito para sa atin, right, ma'am? So kaninang umaga, meron tayong session, no, na antabayanan po ko yun, ma'am.
Yung kay Sir Quesada po na session.
Yes, so napakaganda, no? Ako actually, ma'am, hindi ako math teacher. I'm actually a PE teacher, pero napakalaking tulong para sa atin, no, lalo na sa ating mga learners, na ma-in love sa math, dahil ito ay isang subject na talagang magagamit nila, no? At may in love na sila sa math. I hope you will agree with this, kung tayo talaga ay gumagawa ng paraan para sila ay ma-engage natin dito sa subject na ito, na sabi nila, enemy ng ating mga estudyante. But I don't believe in that, kasi ako talaga, love ko yung mathematics. Kaway-kaway sa aking mga teachers, sila Sir Pagkalisano, I know, kilala rin sa math, no? Sila Ma'am Pactoneri and other teachers sa Las North National High School. So, Ma'am Reg, no, talagang makakatulong itong session natin para sa ating mga teachers.
Yes, sir. And I believe aside from our fellow educators and STEM learners, engineering community is also joining us today para sa session na to, diba? And yun nga po, syempre sa new normal, we need to make some adjustments. So we are utilizing technology talaga in as much as possible para maging better, para maging okay yung teaching learning process natin. So samahan tayo ngayon ng isang engineer talaga who will be speaking about calculator.
Yeah, so with that, Ma'am Reg, take it away. Pakilala na natin ang ating napakahusay na speaker for this afternoon.
Yes, so alam po namin you're very excited na to start the session. So let me introduce today's speaker. He holds a Bachelor of Science in Civil Engineering degree from University of the Philippines, Diliman, where he finished excellently as magna cum laude. He ranked number 1 or top 1 last November 2018 Civil Engineering Licensure Examination with a board rating of 97.20. And currently, he is the structural design engineer of Primo Properties. Ladies and gentlemen, today's speaker, Engineer J.D. Lucero. J.D.
Ayan, so thank you po, Ate Reg, Ma'am Reg, Teacher Ariel. So, ayan, so welcome, Casio Nation, no? So we're here for another MATHtech day. So I hope nag-enjoy kayo sa earlier session kanina, no, nung bandang 9 o'clock. So now we're at 11 o'clock session. So we're here. So for another MATHtech session. So but this time, so we'll discuss matters about engineering. So I hope marami kayong matutunan. So teachers, engineers, engineering students, and STEM students in also. So I hope marami kayong matutunan sa oras na ito. Okay? Yan. So my topic, so my theme for today is discussing the role of calculators in solving engineering problems. So as the title implies, so all problems about engineering yung i-discuss natin. But STEM students and math teachers can also benefit from this session by if we remove the engineering aspects of this session, we can extract the calculator techniques that can also be applicable to math and sciences also. So I hope marami kayong matutunan. Okay. Sige, let's start na natin. Okay. So first, so this is our outline. So I'll be discussing the introduction, and we'll be discussing 4 problems. So sit there, relax, and you can also enjoy your lunch while watching this session. Okay? So start. And so throughout the history, so we have been using calculators to aid us in solving problems, So of course, during the prehistory, we started with an abacus, which can do arithmetical operations, so simple arithmetical operations like addition, subtraction, multiplication, and division. And through technological advances and through complexities, because as humankind, improve knowledge, the more and more complex problems arises, and therefore we need more complex tools and to solve complex problems. So there arise the Napier's bones and of course the slide rule. So actually, slide rule has been in use by engineers ever until siguro mga nasa mid 1900s, nasa 20th century, because at that time, technology was expensive at that time. So slide rules were very popular in as calculators in that time. So slide rules and Napier's bones actually, the function of which is to convert like multiplication and division problems into logarithmic problems, and then using the slide rule, and then using anti-logarithms to be able to compute for the values. So that's how the slide rule works. Okay. But of course, with the advent of computers in the mid 20th century, so there was a desire, for technology or computing technology to be accessible for more and more, students and users, of course, in the world. So with that, so the Casio electronic company started with the Casio 14A brand in 1957. So as you see, so we have a large calculator here. So I'll just open my pen. So you see here, so this is actually the Casio 14A calculator. So it's large enough, So but it can do the basic arithmetical operations and also some scientific operations. Now, with the desire also of getting these calculators as handheld as possible. Pwedeng ilagay sa pitaka, pwedeng ilagay sa bag, and so on. So Casio developed, increasingly, progressively decrease its size of calculator. So starting with the FX1, so this is considerably smaller in size, and until they reach the FX10 brand of Casio. So as you can see, so this one, not only it does arithmetical operations, but also some mathematical and scientific operations like logarithms, trigonometric functions, exponential, square roots, and so on. Okay. Now, today, of course, so we have so many kinds of so many brands of calculators, that actually, pag may mili tayo ng calcu, sa mga bookstores or sa mga electronic stores, namimili tayo kung alin ba yung maganda dito, alin ba yung makakapag-solve, alin ba yung makakatulong sa akin, sa pagsasolve ng mga problems. So there are too many brands, so like this one, the FX991ES, the FX991MS, we have this FX82EXPLUS, and we have also the graphing calculators, so the FX9750. So any brand, so we can use as long as komportable tayo at makakatulong talaga sa atin sa pagsosolve ng mga problems natin. Okay? Ayan. So, for the purposes of this session, I'll classify these calculators into two, no? So the green one, so the highlighted in green, I'll call it the 570 group, and the red ones, I'll call it the 350 group. So remember this well, because all my techniques, all my calculator techniques that I will present later, so all are classified into these two groups, so 570 group and the 350 group. Now the 570 group, so actually is based on the FX-570ES calculator of Casio, no? So that's why it's 570. Now the features of this 570 group, as you can see, it has, of course, this one, it has the ability to solve equations, no? Solve linear and nonlinear equations. It can also solve derivatives and integrals. It can also solve advanced statistical operations, matrices, vectors, complex numbers. So that's usually the feature of the 570 group, as I'm calling. Okay. So on the other hand, the 350 group, no. So the 350 group doesn't have these features, no, like shape solving, derivatives, integrals, like complex numbers, matrices. But what the 350 group has is the basic statistical operations, the tabular operations, and the basic computational operations. That's 350 group. Okay. Now, why I'm classifying this, no, because so nowadays, no, sa board exams, no, it's important to to choose the best calculator, no, that will eventually that will make us faster in solving problems. So actually, so of course, we as of course as even students will choose the one that has more features, no. So usually the 570 group is what the students or even the engineers prefer when calculating, when solving problems. But I will also show in this session that even the 350 group, no, for some reason hindi pa siguro nakakabili ng mga 570 group na calcu, or talagang mas sanay siya sa 350 group na calcu. I will show in this session that some problems that can be solved using the 570 group can also be solved using the 350 group, as long as you know the mathematical principles that can be used as workarounds for this. Okay? So I was able to classify now the calculators. Now next. So by the way, so may two types din ng calculators based sa display. So first is the single line display. So this one, so you have an input here that is on top, no, which is placed on a single line, no. So single line. And we also have the natural display, so which this one, so if you see the display, it displays something that looks like what we can see in textbooks, no. So tulad nito, integral with lower bounds and upper bounds. So they are displayed in the same way as kung paano sinusulat ang integrals. Okay? So this is, of course, students or even engineers prefer using the natural display because, of course, it's more natural, no. So alam natin kung what we see is what we want, no. Ganun yung mga gusto natin. And also, it's less prone to errors kasi alam natin kung paano siya tingnan. Alam natin kung anong itsura niya agad at first glance. So, in comparison to this single line display, so tulad nitong integral nito, it's displayed differently, no. So although hindi naman siya disadvantageous, no, but mas preferred lang ng marami na yung natural display ang gamitin natin. Okay? So let's proceed now to our next one. So so as the title suggests, no, it's the application of calculators in solving engineering problems, no. So gaano nga ba kahalaga ang calculator sa engineering problems? So calculators, it's like our companion. So parang kasama na natin siya during our college days, during our work days, no. So hindi na nawawala sa atin 'yon because lagi nating ginagamit ang calculators in engineering applications. So it can do quick checks, no. Halimbawa, quick check of calculations. Like may pinakompute sa'yo yung boss mo, halimbawa, gano'n, may pinakompute sa'yo yung boss mo, may pinapagawa sa'yo, may tinatanong sa'yo yung boss mo na kailangan computein, no, quickly. So, you can do a quick check sa calculator, and with the result given in the calculator, you can give a decision, you can give a response to your boss, no? Okay? Another one is it can also design, no? So, it can also do design actually, quick designs or quick check of designs natin. Okay? Especially us, no? Especially me na nasa structural design, no? I do quick checks, I do quick calculations if tingin ko mas komportable ako sa paggagawa ng quick calculations. Okay? And another one is also it can be used to investigate, no. Yan ito yung pinaka-paborito ko, no. It can be also be used to investigate. And one favorite example of mine is this one. Ayan. So this is the Sampung Department Store collapse, so which happened in South Korea, so on the 29th of June 1995. So basically this is a if I recall it correctly, it's a 5-story building with 3 floors of basement. So on this day, on that day, this building collapsed, no, which killed 500, more than 500, and injured more than 900. So before the World Trade Center collapse, no, it's the most devastating structural collapse of the history of mankind. Yeah. So of course, being that said, so nagsimula na yung investigation ng mga of course, ng authorities, ng government, and they called upon the services of course, Professor Lanchung. So ito siya. So I'll show a video. Yan. Okay, so play natin. Yan. So this yan. Ayan. So this is Lanchung. So he's called upon the services. So ito 'yon. Ito siya. So what Lanchung did? So ito siya was to inspect the plans. So for checking if it's good based on the design, and recheck all the calculations made by the structural designer. So as a structural designer myself, no, so it's also an interesting. So yun, nakita nyo kanina, no, so he was using a calculator, no, for computing loads, for computing the weights of course yung mga beams and columns, mga biga-haligi, the structural components of the building, and of course it's a companion with the structural code or the design codes, building codes, bale. So, and from the calculator results, and from using the building code or the structural code, so Lanchung found out that there was an anomaly with how the building was designed and how the building was constructed. So that raised suspicion to him. So doon nagsimula yung further investigation niya. So which turned out it was the fault of the owners, no, and the management of the mall, which caused the collapse of this. So kung nakita nyo kanina, no, so the calculator is Professor Lanchung's companion. So it helped him, no, to answer the mystery of why the building collapsed, and was able to solve it, no? Yeah. So that's how amazing. So that's how amazing one application of calculators is to us structural engineers. But of course, there are more applications, no? So which nabanggit ko na rin kanina, no? So it can also apply well to other engineering disciplines like electrical, mechanical, structural, plumbing, sanitary, and so on. So hindi mawawala sa atin ang calculator. Okay? Yeah, so we're done with the introduction, no, for this topic. So now let's start with solving some of the basic problems that we can encounter in engineering discipline. Okay? Yeah, so starting with this one. Okay. So first, we'll discuss in this problem how to solve equations. No? So how to solve single variable equations, and actually use the features of the Casio 570 ES second edition, no, in using the ship solve utility, the equation solvers, and I'll show you using the other calculator, the 350, how to solve it using how to solve it without the ship solve utility. Okay, so let's start. So for this first example, so we have a pipe. So we have this pipe. So it connects a water reservoir. So water reservoir, para lang siyang mga dam, no? Yung mga dam na nakikita nyo sa news. Okay, so that's dam. Okay, that's reservoir. So it's water storage. So the elevation is 48 meters from the mean sea level to a nearby town. So the elevation is 73 meters. And at the pipe entrance, a pump. So the function of the pump is if without pump, the so if it ayan, the of course the purpose of the system is from the water of this reservoir. So we transfer water through this pipe and then deliver water to our constituents in the town. Okay. Now, if yung nilalabas na tubig papunta sa town is insufficient, so nagrereklamo na yung mga residents doon, but ang hina-hina po ng tubig, ganun. So what we can do is of course to install a pump, no, so it energizes the water, no, so and it increases, so it increases the flow rate, so it increases the water output to the constituents. Now, the pump has a rated power of 3 kilowatts at 80% efficiency. Now the water is open to the atmosphere, so at the reservoir, and the water at the nearby town is free flowing. Okay, free flowing. Now, assuming the head loss in the pipe is 50 times the velocity head, find the discharge in the pipe. So the discharge in engineering is denoted by Q, so capital letter Q, as the discharge or the flow rate in the pipe. So meaning flow rate or discharge, gaano karaming tubig ang mailalabas ng system kada second. So yun yung discharge of the pipe. Okay? So now, to be able to solve this problem, so engineers will do this. So we label a point on the surface of the water reservoir as point 1, and at the exit area, so the exit of the pipe, so papunta sa town, as 2, so point 2. Now, point 1 and point 2, so we can relate point 1 and point 2 using what we call the energy equation. No? So the energy equation is given by this formula. No? So I'll explain it one by one. So energy equation, so it relates, no? So kung matatandaan nyo sa physics, yung tinatawag na law of conservation of energy na tinatawag, no? So law of conservation of energy states that energy cannot be created nor destroyed but is transferred from one form to another, from one point to another. So energy equation is a mathematical interpretation of that, of the law of conservation of energy in fluid in this problem, so water supply. Okay, so we have 4 terms on the left side. So P1 over gamma. Okay, so P1 over gamma is what we call the pressure head. Okay, pressure head. Second term Z1 is what we call the elevation head. V1 squared over 2G is called the velocity head. HP is the head in the pump. So P2 over gamma, Z2, P squared over 2G. HT is the head on the turbine. Okay, so which is hindi naman given sa problem, so we take it as 0. And the last one, the last term, is called the head loss. Okay, so head loss. So kung mapapansin nyo, I always repeat the word head. No, so head is basically defined as the amount of energy. No, so energy in the system per unit weight of the fluid. So ganun siya dinedefine yung head of the pipe. So head has the units same as the linear dimension. So head is usually measured in meters. Okay? So now, na-discuss na natin yung energy equation. So let's compute now, no? So first, at point 1, so ito yon, so the left side, so we have P1 over gamma. So P1 over gamma, because based on the problem, it's on the surface. So it's open to the atmosphere. So it's at the surface of, it's the water surface. So it's open to the atmosphere. And therefore, P1, meaning the pressure at point 1, is taken as 0. Okay, so next, Z1 is the elevation from the mean sea level, which is given in this problem as 48 meters. Then V1 squared over 2G is, again, I said it's what we call the velocity head, but it's taken here as 0 because as we all know in this large reservoirs, no, parang hindi gumagalaw naman yung tubig doon, di ba? Parang naka-stay still lang, naka-stationary lang yung tubig doon sa reservoir. So therefore, the velocity V1 is taken as 0 as well as its velocity head. Okay? Then the head in the pump, so head in the pump meaning the energy per unit weight in the pump. Okay, so head in the pump, so it's given by the formula based on the rated power. So the rated power, so this P is equal to the unit weight of the fluid of the water times the discharge times the head in the pump divided by eta, so or the efficiency of the pump natin. Okay, so solving for HP in terms of all other variables, so let's draw this. Solving for HP in terms of all other variables here, so you get HP equals to eta P over gamma Q. So as the head in the pump. Okay. So now, eta, so the efficiency in the pump is already given. It's 80%. So 80%. Okay. So the rated power of the pipe of the pump is taken as 3 kilowatts. Okay. Now, the unit weight of water, so gamma, is taken as 9.81 kilonewtons per cubic meter. So I'll just write it una. No, kilonewtons per cubic meter. So that's gamma. And then Q is the discharge in the pipe. So basically, placing all these values into this equation, you'll get this one. So 3 times 80% all over 9.81 Q. So that's the head in the pump. Okay? Equals, so the pressure at point 2, so pressure head at point 2 is taken as 0 because again, the water at the nearby town at point 2, the water at the nearby town is free flowing. So as you can see, it's open to the atmosphere. So therefore, we can take the pressure at point 2 to be equal to 0. Okay? Plus Z2. So the elevation at point 2 is 73 plus the velocity head. Okay? So the velocity head, which is V squared over 2G in this energy equation, we can rewrite it in terms of the discharge Q. So recalling that the velocity of flow of water inside the pipe is equal to the discharge over the area or the cross-section area of the pipe. So it's V equals Q over A. No, we substitute it to the V here. So you'll get Q squared all over 2G times A squared. Then we now substitute for the area because the area of the cross-section, which is a circle, is pi over 4 times the diameter of the pipe squared. So we substitute that for the area of the pipe. And then simplifying, you'll get 8q squared over pi squared gd to the 4. Now this quantity, so 8 all over pi squared g, we can actually compute it now in the calculator and get 0.0826 q squared over d to the 4. So that's the working expression for the velocity head in terms of the discharge q and the diameter d of the pipe. Okay, so 0.0826 q squared all over d to the 4. So pasok na natin dito, no? So 0.0826 q squared all over 0.4. So because it said in the problem the diameter of the pipe is 400 millimeters. So 0.0, so the d here is 0.4. So raised to 4 plus HT. So the head in the turbine is 0 as said in the problem. So 0. And then the head loss, because based on the problem, the head loss in the pipe is 50 times the velocity head. We just multiply this by 50 and add it to the energy equation. Okay, so that's is that clear? So this equation, so that's very long discussion, but what I want to point out is that this is our working equation for this problem, and that this is where our calculator techniques start for this problem. Okay, so now the first method, of course, the first method that I will show is using the ship solve, no? So the first method that I will show is, of course, using the ship solve, no? So first, let's input the equation. So 0. So input natin plus, plus 48 plus 0. Then plus fraction 3 times 80%, no? 80. So this is the percent sign, percent divided by 9.81 Q. So Q is the unknown. So Q is the unknown variable here. So we let this as X. So shift X, so alpha. So alpha X. Okay. So next, equal. So alpha, this one, alpha calc. So this is the symbol for the equal sign. No? So if you're not yet familiar with these kinds of calculators, no, so please always remember that shift. So the labels above these keys so are color coded, no? So with the yellow ones being activated using the shift button and the red ones being activated using the alpha button. Okay, so equals 0 plus 73 plus, so itong fraction na to, so 0.0826 alpha q, so x squared divided by 0.4 raised to 4 plus 50. Actually, mapapansin nyo, if you can notice here, this one and this one are like terms, right? So they are the same. So meaning, the coefficient here, which is 1, and 50 here, we can combine these two. No? So to give, so we can combine these two to give 51. So 50 plus 1, that's 50. Okay? So we have this equation. So let's check if it's correct. Okay, yes, that's correct. No? So this is our working equation. So which we just have inputted in this calculator. No? So now let's press shift and then calc. Okay. Now after that, you are being asked for the value of x. No. So this is a guess value, and any value and any good value will do. I'll explain it later why. Kailangan good value. So for this problem, I'll say sabihin natin 0.009 is the guess value for the value of the variable. I'll just input it and then press equals. You'll get this value. No? So the value of x is so it's the value of x is 9.779 times 10 to the minus 3. So meaning the value is 0.00978 cubic meters per second. So that's the value of the discharge Q. That's the value of the variable Q. Okay, so I hope that's clear. So that's how we apply the shift solve utility to this equation. No? So that's straightforward. Input equation, shift calc, enter a guess value, and then press equals. If the approximation is good enough, you'll get the correct answer. So that's okay. Okay. So now so napansin natin kanina, we inputted a guess value, tama, no? So it's based because the shift solve procedure is based on the Newton-Raphson procedure, the Newton-Raphson method. So basically, if we have this equation, no, represented by this graph, so and you have a guess value. So for the problem kanina, ang guess value natin is 0.009, no? So we have a guess value x naught, no? And then evaluate, no? And then using the Newton-Raphson procedure, we construct a tangent line, no? An approximation. So a tangent line to this one. So ito yung point kanina. So you draw a tangent line and you'll see that it intersects the x-axis or the root. So the root finder at a second point, which is x1. So of course, x1 is not yet the desired answer. The desired answer is this one. So, which is the point where the graph or the equation intersects the x-axis. So, this is our real answer. But, nandito pa lang tayo, no? So we repeat the process. So, we evaluate at x1, draw a tangent line, and then take the intersection to the x-axis. So, this is our new point, x2. Okay? Again, evaluate the function at the value of x, draw a tangent line, and then take the intersection at the x-axis. So as you can see, now if your approximation is good, or if approximation is right, so if you see the value of the approximations come closer and closer to our desired value of x. So x0, x1, x2 come closer to this root. So eventually, the error is small enough that we can now consider the value that we get using Newton-Raphson as the correct answer for us the correct root. Okay. Now again, we need a good value. Otherwise, you get problems dealing with this. No? For example, your guess value is here, no? And then we draw a tangent line. So, ano na nangyayari? So, the tangent line goes somewhere. Hindi na natin alam kung saan papunta, no? And in the calculator, no, so it will manifest, no? You'll see, sobrang tagal mag-compute nung calculator nyo. It takes too long. So, wala na. Naka-blank screen na siya dyan. And you'll be like this, confused ano nang nangyayari dun sa computation nyo. And then, eventually, may kita nyo sa dulo, it's cannot be solved. It's because the ship solved cannot find a good route, the correct route, because dito pa lang tatapon na, hindi na nag-intersect siya doon sa x-axis natin. Okay? So that's why Newton-Raphson procedure is sensitive to of course, it's sensitive to yung good value of approximation natin. Okay? So that's how Newton-Raphson method works. Now, of course, kung nakita nyo kanina, di ba, the Newton-Raphson procedure, no, or the ship solve, no, gives only one root. But if you look at this equation again, so we can write this, no, lipat lahat sa left side. So this one, and then multiply both sides by q. So we can see that this is a cubic equation. But yeah, we can see this is a cubic equation, but we only have got one value kanina, no? So saan natin makukuha yung dalawa pa, no? So because this is a cubic equation, we expect 3 roots, but we have gotten 1. So we need to find 2 more to verify that yung nakuha natin kanina is the correct answer for this problem. Okay? So that's where yung pangalawang method, no, which is yung paggamit ng equation solvers take into place, no? So okay, so let's just open muna. Open. Yeah, so let's now go to our second procedure. So our second procedure is to use the equation solver. So if you have this 570, you can use, so we can press mode here and then choose 5, no, which is equation solver. Now, after pressing that, you can see that there are 4 choices. No? The first 2 are for systems of linear equations. So, hindi natin papansinin yan. The third one is for quadratic equations. And the fourth one is for cubic equations. And since our equation is cubic, we'll deal with this one. So, yung pang-apat natin. So, press 4. And you see now there are 4 coefficients here, 4 values here that we need to input corresponding to the coefficients of our equation. So we have here for the coefficient of, so A, which is the coefficient of the cubic, no, the cubic exponent, coefficient of q cube, we input negative 51 times 0.0826 divide 0.4 raised to 4, okay, equals B, coefficient of x squared, okay. So but here wala tayong x squared, no, so we left it as 0. Third, letter C, which is the coefficient of x, so which is here, the negative 25. And last, letter D, which is the coefficient or the constant term, so which in this case is given as, and so which in this case is given as 3 times 80%, no, so 80% divided by 9.81. That's it. Ayan. So we have now this equation, no? We can now press, after inputting all the coefficients, we can now press equals. And now get the first value, which is the same as before. Ito yung una natin. Tama? But our interest is the second and the third roots. And as you can see, the second root is an imaginary, is a complex number, which is hindi naman allowed dito sa problem na to, okay? And the third root is of course also an complex number. So therefore, this verifies that this one is only the root of the equation and also the answer for this problem. So I hope you got it clear, no? So again, in summary, this is the coefficients. So for the cubic, second, single, and constant, which is to be inputted into the equation solver natin. Okay? So next, we now present the third method, no? So makikita nyo sa label natin, it's now the 350 group na, no? So it's the 350 group. Meaning, so the 350 group, wala nang shift solve na gagamitin. So, okay. So now, we now use the tabular method for calculating the root of this equation. So magbubukas ulit tayo, no? Okay, so magbubukas ulit tayo ng magbubukas ulit tayo. So this time ito naman. Okay, so this time ito naman. Yeah. So this one is the 82. So FX82 85 350ES plus second edition. So again, sabi ko kanina, the difference is that wala nang shift solve, wala nang derivatives, integrals, complex numbers, vectors. Bale, ang makikita mo na lang na modes natin, if you press mode, it's just this, no? Computational mode, stat mode, and table mode. But of course, kahit ito lang naman yung feature niyan, we can solve this equation gracefully, no? So, we start with the table mode, no? So again, mode 3, table mode. So we are presented with this function f of x. Okay? So, balik muna tayo dito. So f of x, so again, we rewrite this so that the equation is on the left side. Nasa left side lahat. This one. And then this left side, to. So this left side of the equation, we label it as f of x. Okay? So this is our f of x. So let's now compute. So input natin to. So negative 51 times 0.0826 x squared over 0.4 raised to 4 minus 25 plus input natin 3 times 80%, okay, divided by 9.81x. Okay. Now press equals. Ayan. Now dito you'll be asked with start, end, and the step. No? Let's take the start as 0. Let's take the end as, for example, 0.01. And let's take the step as, for example, 0.001. So meaning, what I inputted earlier is that it starts with the value x equals 0, ends with value x equals 0.01, and then steps at 0.001. So 0.001, 0.002, 0.003, 0.004, and then evaluate everything at those intervals. Okay? So if you press equals now, you'll get this. Okay? So these are the x values incremented at 0.001, and these are the corresponding values of f of x. Now, based on this equation, we want f of x to be equal to 0. So we'll search for that, no? So if you search here, search here. So wala tayong makitang 0. But we find an interesting feature, no? So which is this one. So balik ko na dito, which is this one. So if you have noticed, no, dun sa lumabas na output kanina, so we highlight this 2, you notice that the value of f of x at this point is positive. No, it's positive 2.16. Whereas the next value of x has this value of f of x, which is negative. Tama? So we have this positive, we have this negative, and therefore, using yung tinatawag natin na intermediate zero theorem, no, sa calculus or algebra. So by the intermediate zero theorem, if there's a value that's positive and the next value that's negative, we are sure that there is at least one value of x. There is at least one value of x wherein yung value ng function is equal to 0. So between these two So between these two, we have a 0, no? So yan yung i-consider natin ngayon. So because of that, okay? So because of that, let's now consider this value of x, so 9 times 10 minus 3 as the new starting point, and this one, 0.01, as the new ending point natin. So that's where the next iteration comes in. So compute ulit natin. So ito siya. So okay. So press AC, no? Again equals. So we are again asked with the start and the end values. So we're now input 0.009 and value is 0.01, so desired. And then the step now, we go one notch down. No? We go divided by 10, so 0.0001. So equals is, so again, searching for those kind of values na positive, negative, no? So we search for this one and you see this. Ito naman. So ito na yung makikita natin ngayon, no? So makikita nyo, this one is positive, then becomes negative at some point. So, okay? So meaning, the 0 lies between these terms, okay? Now you can continue the process, no, of tabulation, start and step, until you can get the desired number of decimal places of accuracy. So okay? So I hope you got it, no? So, and you can see the answer is the same, no? Approximately the same as yung kanina natin, which is 9.77 times 9.77 times 10 to the minus 3 cubic meters per second. Okay? So that's it for our first problem, no? So napakahaba ng discussion natin, but we were able to discuss how to solve just this single problem using ShipSolve, using equation solver, and using this tabulation method natin. So if you have a 350 group calculator, so huwag kayo mawala ng pag-asa if you encounter this kind of equation, it is still solvable using this procedure. Okay? So now, let's proceed to our second problem. So this time, it's solvable either using the 570 group and the 350 group. No? So which relates to checking stresses in beams. So the problem goes like this. So you have a beam, no? You have a beam 6 meters loaded with a 30 kilonewton per meter uniformly distributed load, and we have this section as shown, no? So the problem asks for the maximum normal stress in bending experienced by the beam. Now, just an introduction sa mga STEM students natin and sa mga math teachers, no? So, if meron kayong mga bahay, no, na ginagawa, meron kayong mga 2-story or 3-story na houses, so you'll see yung mga bahay ninyo, may mga parang rectangular shape na parang concrete na naka-traverse doon sa may ceiling, no, ceiling ng mga bahay ninyo. So that's an example of beams, no, as applied to structures natin. So this beam, so it's carried this load, so we are asked to determine the maximum normal stress. Now the maximum normal stress in mechanics of materials, so this is in the subject of mechanics of materials, is computed using the formula sigma, so the normal stress is equal to MC over I. So M is the maximum bending moment experienced by the beam. So what's this bending moment, no? Because the beam is loaded like this. So pwede nyo isipin, when the beam is loaded like this, meron kang beam, tapos binigatan mo. Yan sa Tagalog. So binigatan mo. So nilagyan mo ng bigat. Halimbawa, tumayo ka dun sa beam, or nilagyan mo ng mga boxes, storage, etc. So that's some ways para bigyan mo ng bigat yung beams natin. And when that beam is loaded, so it deforms something like this. So it deforms. So in the shape something like this. Okay? So ito 'yon. And this load and this deformation is also due to the internal forces that happens in the cross sections of the beam natin. Okay? Now, along this, so if we cut a section, of course, ganito yung lalabas sa kanya. So the internal forces are distributed, no, doon sa cross section natin, such that each part of the cross section is also loaded like this. Now, mapapansin nyo, this part ayan, kung mapapansin nyo, ipapalakihin ko lang. So this part is, it is being pushed into the cross-section. No? So this part of the cross-section is called compression. No? So parang pinipipi nyo yung cross-section nyo. Parang kinocompress nyo siya. So that's compression. No? The other part, which is at the bottom, so ito naman, is it is being pulled. No? Parang hinihila yung section ninyo. No? So in this case, that part of the section which is in pull is called the section which is in tension. No? So meaning the upper part of the beam is in compression, so pinipipi siya. Then the lower part of the section is in tension. So meaning hinahatak siya. So yun yung meaning ng figure na to. Okay? So now, kung mapapansin nyo, somewhere along this, there is a part of the cross-section wherein the force experienced in the cross-section is 0. No? And that force on that part of the section is what we call yung tinatawag na neutral axis. So, sulat ko lang muna, no? So, ang tawag dito ay neutral axis. Ayan. So, this is the neutral axis. And the objective of this problem, of course, is first to find the location of this neutral axis or the location of 0 stresses in the beams natin. Okay? So, first, let's compute M. So, M, based on mechanics of materials and statics, it's computed using omega L squared over 8. So, where omega is the distributed load on the beam, which is 30 kilonewton per meter. L is the length of the beam, which is 6 meters. So, we substitute that, you'll get 135 kilonewton meters. So, that's for the maximum bending moment experienced by the beam natin. That's for M. But what is the C? Itong C na to, itong I na to. So, confused screams tayo. So, this is still in question mark. But we'll explain it today. Okay? So, C here is the distance from the most extreme surface of the beam to the neutral axis. Actually, there are two surfaces here, the one at the bottom and the one at the top. But as we can see in this figure, the one at the top is farther from the neutral axis than the one which is at the bottom. So therefore, C is taken at the top. So yung top yung kukunin natin. Okay? So now, the objective of this problem using calculator techniques is to calculate for C and I. And I is the moment of inertia of the section natin about the neutral axis. Okay? So let's now start computing. So we are asked to compute for the C. So let's designate the bottom surface as the x-axis and the one perpendicular above as the y-axis natin. So therefore, we now calculate this, the y bar, or the distance from the x-axis to the neutral axis, which eventually gagamitin natin siya to calculate this, the value of C. Okay? So let's label the figures. So 1, 2, 3. And also, makita nyo, there are red dots and yellow dots appearing here. So this is what we call, this one. So this is what we call the centroid of the cross section. So this is what, natin. So this one is called the centroid of the cross section. So if para siyang, iisipin nyo, para siyang center of mass. Yeah, center of mass. Kumbaga, if you have an object, if you can lump it into a single point, so into single point with the same mass, with the same properties as the original one, then that point is located at this one, which is the centroid of the object natin. Okay? So that's what centroid is defined. So now let's compute So first, the location of the centroids from the x-axis, so which is designated as y bar. Okay? So first, let's calculate this one for 1. So the distance from the x-axis to the centroid is this one. Tama? Yan. Papunta dyan. So that's y bar for the first object natin. So the distance papunta dyan is equal to this distance, 100, plus this distance, which is 200, plus half, again, for rectangles, the centroid is half its height. So meaning kalahati nung 50. So plus 50 over 2. Okay? Next, the centroid of the second one is this one, papunta dito. Yan. So it's equal to this distance, 100, plus half of the height of this rectangle, which is 200 over 2. Finally, the centroid of this, the distance being this one, so it's equal to the half of this height, no? Which is 100 over 2. Just clear? Next, let's compute for the areas, no? So for the areas, for the first object, so which is a rectangle of 300 by 50, for the second one, which is 200 by 75, and the third one, which is 400 by 100. Okay? Also, let's compute the moments of inertia about their centroids, no? So papunta dito. So and we know from the statics, no? So from statics that the moment of inertia for rectangles is 1 over 12 times the base times the cube of the height of the rectangle natin. That's how moment of inertia is computed using rectangles natin. So we have 1 over 12 times for the object 1, so base is 300, the height is 50, so 50 cube. Okay? Then 1 over 12 times for the second object, so 1 over 12 times the base, which is 75, times the height, which is 200 cube. And finally, so the third object, which is 1 over 12 times the base 400 times 100 cube. Okay? So that's we compute the moments of inertia. Okay? Now, let's now compute. Let's now apply the calculator techniques that we have to solve this C and I. Okay? So let's proceed with the 570 or kahit ito lang 370 natin. So sapat na. So we now go with the stat mode. Dito tayo papasok. Stat mode tayo. No? Stat mode. And if we know dito stat mode, meron tayong option dyan. There are 8 options designating kung anong fit. So, anong regression fit na tinatawag yung gagamitin natin dito. But dito, for this problem, di naman tayo nagre-regression dito. We are not fitting lines or curves here. So, we'll use the one var here. So, the single variable option. So, press 1. So, we'll go. So, it will bring you to this feature. Now, we have this activate. So to be able to input the second column, let's now activate the frequency mode for the stat. So press shift and then mode and press down. You'll see stat here. So 3 and then 3 and then you'll ask if you can on frequency. So let's on frequency. And now there appears a second column for this one. Now, bakit inactivate natin si frequency? It's because we have 2 columns here. So the y bar, y bar is corresponding to the value of x of this, and the area A corresponds to the frequency here of this calculation. Okay? So now let's input now our values. So 100 plus 200 plus 50 over 2 equals. So as you can see, the default value of the frequency is 1, but we can change it today. We can change it later. So next column, next row, 100 plus 200 over 2 equals. Last column, so 100 over 2 equals. Okay, so na-input na lahat. So let's now proceed to the frequency, yung areas natin. So punta tayo dito. So areas, so we have 300 times 50 equals, then 200 times 75 equals, and then 100 times 400 equals. So ayan. So as you can see, we have inputted the y bar and the A into this stat mode natin. Okay? Now press AC. And babalik tayo dito. No? So now, let's calculate first the centroid y bar of this. The y bar of this is equal agad-agad. to the mean of this statistical data natin. Okay, mean of the statistical data. Later, i-explain ko bakit equal siya sa mean. No? So, let's just calculate the mean first. So alt tab tayo. Ayan. So, okay. So, calculate na natin yung mean. So, shift, so makikita nyo dito sa baba, sa taas ng 1, there is a stat mode here, no? So, press that. So, 1. So, papunta tayo dito, no? Then, press var. So, punta tayo sa var, meaning variable, no? So, var. So, 4. So, you have 4 options here. So, first, number of data. So, n, x bar is the mean. Sigma x is the population standard deviation, no? And sx is the sample standard deviation. But for this problem, pinapahanap lang naman sa atin is the mean, no? The mean. So, let's do just x bar. So, x bar equals 141.07. Diba? Ang bilis. Ibig sabihin, the centroid, y bar, so yung distance from the bottom surface to the neutral axis is equal to 141.07 mm. And therefore, C is equal to 100 plus 200 plus 50. So basically, that's the total height of this section. So 100 plus 200 plus 50 minus y bar. So 141.07 equals this one. Yung value ng C na matagal na nating hinahanap. So it's equal to 208.93 millimeters. Now, in your calculator, pwede nyo gawin to. So, alt tab natin. So, in your calculator, di ba, nahanap na natin si x bar. So, you can now calculate, no? So, 100 plus 200 plus 50. Then, shift 1. Then, bar 4. And then, x bar here. Kalimutan ko yung minus. So, minus x bar, you'll get 208.92 as the same tayo dito. So, same as this one. Okay? So, you can actually solve, you can actually store this na, no? Store at A. So, para for easy reference natin mamaya. So, shift store A for easy reference natin. Okay? Now, nahanap na natin si C, no? Now, let's find I. So, I at the neutral axis, no? Now, I at the neutral axis is equal to this. If you have, diba, na-compute na natin kanina, yung centroidal moments of inertia, at their centroids, of course. So, you add all this. So, add all these three, and then add this term. N sigma x squared. Yan. So, as I said earlier, N is the number of observations, and sigma x squared is sigma x is the population standard deviation. No? So, I'll explain later again bakit ayan yung idadagdag natin dyan. Okay? So, punta tayo ngayon. So, add natin ngayon. So 1 over 12 times 300 times 50 raised to 3. Okay? Plus 1 over 12 times 75 times 200 over natin cube. Okay? Plus 1 over 12 times 400 times 100 cube ulit. Then plus n sigma x squared. So plus, punta ulit tayo sa shift stat 1. Punta ulit kayo sa bar 4. And then press n, which is 1. Lalabas si n dito. Then let's press again shift 1. So var. And then do the sigma x 3. Then we square sigma x squared. And you get this one. So 977.752 times 10 to the 6 millimeters to the 4. That's our centroidal moment of inertia about the neutral axis. Okay, I hope that's clear. So let's now calculate now. So we have now obtained C and I at the neutral axis. So we can now solve for sigma equals mc over I. So m is 135 as we have calculated earlier, but we times it by 1 by 10 raised to 6 so that our final answer becomes a megapascal. Okay, times our C earlier, that's 208.93, and then our I, which is 977.75 times 10 to the 6. Now, this, ito muna, I just forgot. This one, so let's now calculate this. So 135 times 10 to the 6 times the centroid times C, so which is at the variable A, if you have listened earlier, then divided by the moment of inertia I, which is stored at the variable B. And you get this one, 28.85 megapascals. Okay, that's clear? So, that's how we obtain yung sigma, yung maximum normal stress in bending experienced by the beam. And the second question is that the allowable normal stress in bending is 30 megapascals. So 28.85 is way less than this 30 megapascals. So we say, okay, no? So meaning, because 28.85 is less than the limit, which is 30, we can say that this beam is safe under the given loading natin. No? So we can now say this is safe. But of course, no, in the spirit of structural design, no, we know that changes in the loads can make these stresses exceeded, no. So you need to check, no, other cases. But this, for this session, no, this is just a basic example of how to check whether structure is safe under the given weights or the given loads. Okay? So why? So yan. So as I said earlier, I'll show this. I'll show bakit yung kanina we compute the centroid using the mean, and by the moment of inertia using the n sigma x squared natin. Okay? So this is the derivation. So I'll show it. So I'll show here that calculator techniques that exist in engineering, no. So these they are numerous, and actually there are pioneers, no, in the calculator techniques. So salute to them, okay, for the calculator techniques. So the calculator techniques in engineering are numerous, and actually they are founded in theory, no, in principle, no. So let's show yung calculator techniques natin kanina is founded in theory. So we have first the centroid, no, y bar, no. We know that the centroid of the objects is equal to this, no. So a1 y1 plus a2 y2 plus a3 y3 all over a1 plus a2 plus a3. So this is from statics, no. Now in summation notation, no. So I hope STEM students aware kayo dun sa tinatawag na summation notation. So we can now convert it in summation notation as this one. So summation of ay over summation of a. Okay? Which basically, this one, so familiar tayo dyan. This is just sigma x over n, no, in the calculator. So sigma ay is just the weighted sum, sigma x, and sigma a is just the total frequency, no, in the calculator technique discussed earlier, which is just the total number of observations n. And sigma x over n, which is we are familiar, is the weighted mean of this object. Okay, so that's y bar. Now the moment of inertia about the neutral axis is calculated earlier, is calculated as I per object as I1 plus A1 D1 squared. So as A1 D1. So now A1 D1 squared. So I1 is the moment of inertia about the centroid. So nakalculate na natin yan kanina in the tabular form. Now this one, so A1 D1 squared is the effect of what we call the parallel axis theorem, no, in statics. So parallel axis theorem effectively transfers the moment of inertia from the centroid of the object to any axis, no. So that's adding A1 D1 squared. So that's for the first object. We do it for the two other objects like this one. Okay. Then we group the centroidal moments of inertia. So I1, I2, I3. And then we group this A1, D1 squared. But first, let's define D1. So D1 is the distance from the centroid D1 to the neutral axis. So basically, this is your D1. And it's equal to the distance of this centroid papunta dun sa bottom x-axis natin minus y bar natin. So, substitute. So, y1 minus y bar squared. So, doing it for the other objects, you'll get this one. Now, let's start the grouping. So, I1 plus I2 plus I3, and then grouping A1, B1 squareds. Okay, so that's grouping. And then we express it in summation notation as this one. So, summation of IK plus the summation of A, YK minus Y bar scale. Now, this one, IK bar is yung mga 1/12 BH cube na pinag-a-add natin kanina. That's it. Yan yun, yung rectangle. Again, that's for this part. Now, this one reminds us of what we call the weighted variance of the distribution in statistics. Now, the variance, weighted variance, as we know, is a summation of frequency times the square of the difference from the mean divided by the number of observations n. And then solving for this quantity, so that the numerator, solving for this numerator, you'll get n sigma x squared. The same as what we see earlier, n sigma x squared. And now, this and this correspond to each other. So nk, the frequencies, is the areas of the cross sections, ak, and xk bar minus x bar corresponds to yk minus y bar. So therefore, we can now substitute n sigma x squared, and we now get this calculator technique for the moment of inertia. So as you can see, so you can see the calculator techniques are not just developed somewhere. It's not magic. It's based on theory. It's based on principles of statics, of engineering, that if we combine them together, we can form a systematic calculator technique that we can use to solve problems easily, like this one. Okay? So that's it. So I hope you understand this, no? So we are now finished with the second problem of this session, and let's now go to the final example of this session, which I believe is also important, no, in engineering. So which deals with forces, no, so forces in object. So the problem goes like this. So find the forces in each leg of the tripod. So this is the tripod loaded with a 150 kilonewton downward force as shown in the figure. Now, this is the 3D problem, no. So actually, we in engineering, medyo kinakabahan na kami if the problem involves 3D. Actually, 2D is easy to solve, but when we extend it to 3D, it's actually challenging, no. But it's worth it if you have solved it. Yun. So this is the problem. Now, how do we solve for the forces in each leg of the tripod? So each of this tripod is pinned at the support, no? Meaning pinned. So meaning here, here the motion of this end is restrained. So meaning hindi siya makakagalaw at this axis, but it can rotate at this point. So that's how pinned end is defined. Now this one, so this end is can be moved, no? Can freely move in any direction, can also rotate in any direction. So it's really free in the aspect. Okay. Now let's now compute, no, the forces. So the forces here are, so by the way, let's label the axis, no? So this is the x-axis, the y-axis, and the z-axis. So basically following the right-hand rule, no, in labeling the axis natin. Okay. Now let's label the forces. So these are the forces. So why is it like this one, like this way? So we know that the force is downward here, downward to this point. So the direct effect of this force on this legs of the tripod is that it's being compressed. So pinipipi siya, no? So therefore, in order to counter the effect of this compression on this member, so the effect is at this joint, yung member natin is parang itutulak niya yung joint natin in order to parang resist yung compression effect ng force na to. So that's why the forces in red are directed towards this point. Bale, ito siya. So we now label this as 4 and member 3-4. Now we label the points. So this point 4 is 0, 0, 12, no? So point 1 is 5, negative 3, 0. Point 2 is 6, 9, 0. And point 3 is negative 3, 2, and 0. Okay? So we label the points so that later the computation will be much easier. Okay? So now let's compute now. So first with the member 1, 4, we know that member 1, 4 starts with member 1 at 5, negative 3, 0 and ends with point 4 at 0, 0, 12. So therefore, we now calculate yung tinatawag na magnitude. Okay? The magnitude of this vector. So basically this one, these are forces. They are also what we call vectors, no? So vectors. So vectors, as we know in math, so vectors are quantities which have magnitude. So meaning, what's the value of it? And also direction. So meaning, saan papunta yung value natin. So vectors of magnitude and direction. So basically, forces like this are vectors. No? So we now calculate first the magnitude of the vector. No? So this is given by the square root of the differences in x coordinates. So the final point is 0, initial point is 5, so 0 minus 5 squared plus, again, so for the y coordinates, so final minus initial, so 0 minus negative 3 squared, then plus for the z coordinates, so 12 final minus initial, which is 0 squared. Basically, this is the magnitude of this vector. Itong directions na to. Now, this one, we store it in the variable a later in the calculator natin. Okay? Remember, so by the way, this is the matrix. No? So, this is the matrix. So, we now place these values like this. So, the first one is this one. Ito. So, 0 minus 5 divided by yung magnitude, which is A. Okay? Then on the second line, so we have 0 minus negative 3 here on the top divided by the magnitude A. Then last, we have this 12 minus 0 divided by the magnitude A. So that's we put in the first row of this matrix natin. Okay? Now, for the second member, so member 2, 4, so we know that member 2, 4 starts from point 2, which is 690, and ends with point 4, which is 0, 0, and 12. So calculating the magnitude, so we have this, so similar process, and then store it into the variable b of your calculator. No? And the matrix here, so the matrix here, we place first the x coordinate 0 minus 6 divided by magnitude b, then the y coordinates, so 0 minus 9 divided by the magnitude p. And then this one, 12 minus 0 divided by the magnitude c, the magnitude b of the matrix. Okay? So, ayan. So next natin, so we have finished the, ayan. So we have finished the second row. Next is the member 3, 4, no? So member 3, 4 starts with point 3, so negative 3, 2, 0, and ends with 0, 0, 12, no, which is point 4. So calculating again the magnitude and then storing it to the variable c. And then we start it with point c, no? We now complete the last column, no? So first we have the x coordinates here. So 0 minus negative 3, so divided by the magnitude c. Then the y coordinates 0 minus 2 divided by the magnitude c here. And then 12 minus 0 divided by the magnitude c, which is placed here. Okay? Now, times. So this one, we place now the missing forces, no? So F14, which is this one, F24, which is this one, F34, which is this one. So F14, F24, F34 equals. So equals the applied forces that we have, no, in X, Y, and Z directions. So in X direction, wala nang ibang applied forces dyan. So we know, by the way, to make this clear, no, so the only applied force here is this one, 150 kilonewtons, 150 kilonewtons downward, so at the Z axis. So that's the only applied force in this system. Therefore, the X and Y axis uh, uh, receive zero applied forces natin. And the Z-axis has 150, yun, 150 kilonewton applied force natin. Okay. So now basically we have this matrix equation, no? So or if you think it in another way, this is a system of three equations in three. You can solve it using the system of equations solver, no? But I'll show in this problem, no, how to use matrices in solving this problem, no? So we now label this matrix A. So this is the matrix answer. So this is what we desire. So we need to find these forces, okay? And then matrix B. Now all the preparations are ready. So let's now input it in our calculator. So let's close it first. So let's close it first. Okay. Yeah, let's close it first. Okay, so let's close it first. And then ayan. So let's close it first and then use. So because matrices, we use this. This one. Sorry for that. So we use this one. No, we use the 570 group, no, as labeled above. So the 570 group, because matrices are only available in 570 group calculators natin. Okay, so let's clear first. So set up. So now let's now go to the matrix mode here. So matrix mode is mode 6 here. So we are now asked with this. So matrix A, matrix B, matrix C. So Casio FX-570 groups, no, is supplied us with three matrices. So first with matrix A. So matrix A natin is here. So which is 3 by 3. Okay. So but before that, so that's matrix A. But before that, we first store yung magnitudes natin into the variables A, B, and C. So starting with this one. So 0 minus 5 squared plus 0 minus negative 3 squared plus 12 minus 0 squared. So equals, actually, pwede na natin i-store directly, shift store A. So you can see, it's now stored in the variable A. Okay? Next, for the second variable B, so let's input 0 minus 6 squared plus 0 minus 9 squared plus 12 minus 0 squared. So input again. So shift store in the variable B. So 16.155. And then for the third variable, so we have here square root of 0 minus negative 3. Okay? 0 minus negative 3 squared plus 0 minus 2 squared plus this one, 12 minus 0 squared. Then store it in the variable C natin. So 12.529 something. Okay? Now, these variables have been stored already. So let's now proceed with the matrix mode. So shift matrix. So as you can see it, shift matrix, you are now asked with this. Tama? So start with data. So data to matrix A. So we have this 3 by 3 matrix. You can now input these values one by one. So starting with 0 minus 5 over A. Okay. Then we have on the second column 0 minus 6 over B. Over B. Here. Verify lang natin. 0 minus 5 over A. Okay, tama naman pala. So for this column, so we have 0 minus negative 3 over C. Okay, tama. So we have this one. Then for this second row, so we have 0 minus negative 3 divided by A here. Then 0 minus 9 divided B, which is here. And then last one, so we have 0 minus 2 over, over C, which is this one. Okay. Now, for the last row, so we have 12 minus 0 divided by A. Okay. Store. Then 12 minus 0 divided by B, which is this one. And then the last one, which is 12 minus 0 divided by C, which is this one. Okay? So that's for the matrix A natin. Okay? So press AC, then shift matrix. So shift matrix 4, and then let's go to the matrix B natin. Okay? So matrix B. So data, matrix B. Then this is and one column. So we press 3 by 1. Okay? So 3 by 1. So makuha nyo naman na tama siya if the itsura or the appearance of this matrix matches with what is written here. Okay? So 0, let's input 0, 150. Close. Okay? So now let's compute now for the matrix answer, which basically is the inverse of matrix A times matrix B. So matrix A, let's extract matrix A. So shift matrix, matrix A. So we press matrix A, then inverse. So if you see here, where's that? Where's the inverse here? So raise to negative 1, okay? Raise to negative 1. Then times the matrix B. So matrix, so shift matrix B. Tama? Syntax error. So syempre, that's not the way we do inverses of matrices. So alam nyo, tama na, no? So this is not the way to compute for the inverse of matrices. So this is not. So hindi siya parang yung nire-raise mo lang ng negative 1 normally, you get the inverse of the matrix. Now, for matrices, Casio has, nabura ko siya. So, for matrices, Casio has a built-in inverse of a matrix. So, this is, this symbol, x raised to negative 1, calculates the inverse of any quantity, matrices included. So, press natin to, raised to negative 1. So, that's the correct way of calculating the inverse of matrix. Matrix A raised to symbol times matrix B. You'll get this one. So you see, so we have 64. So 64.396 as for the force on member 1,4. So negative 1.99 and 97.696. So this is for F14, member 1,4, member 2,4, and member 3,4. So now, to interpret this, no, we have assumed that the answer is compressive all the time. No? So compressive lahat dito. So we have assumed that the answer is compressive. However, we notice that the second one, the F24, is negative. So it's compressive in assumption, but it's actually negative. So therefore, it's the opposite. So meaning, this one is actually tensile in nature. Dapat. So the other two are actually Ayun, the other two are actually actually compressive in nature because the assumption are correct because the what we got is positive. No? But the second one is negative, so therefore it is tensile in nature. Okay, so that's how we apply, the matrix operations in order to solve this 3D challenging 3D problem. Yeah. So okay. So I hope marami kayong natutunan, no? So that ends. So that's our last example, and that ends that ends my discussion, no, for today. So I hope, no, for the STEM students and for the math students, marami kayong na-apply. Marami kayong natutunan, no? Even if the examples are engineering examples, marami kayong nakuha na techniques from this. So involved including yung shift solving, yung tabular method, yung sa statistics mode, no, yung pagkuha ng mean and standard deviation, no, and this the matrix mode, no. So that's it, no, for today. So I hope marami kayong natutunan. So I'll giving now back the floor, no, to Teacher Ariel and Teacher Reg, no, for the closing remarks, no. So that's it for today. So maraming salamat sa pakikinig. So thank you very much.
Alright, sobrang loaded yung discussion. And as we can observe, hindi lang po limited sa mathematics, yung mga science concepts na dun sa discussion in solving engineering problems. And syempre, we utilize technology by using calculator softwares and yung calculator models din mismo. Nakikita ko sa mga comments, sabi nila, yung iba nakaka-relate na helpful daw yung techniques or yung iba nagamit din daw nila sa classes nila. So even teachers na-appreciate yung discussion. So thank you so much, Sir JD, for that discussion. Sir Ariel?
Yes, thank you very much, Engineer JD Lucero. Napakaganda yung discussion. No? Talagang, you know what, magagaling ang teacher natin, no? Magaling na yung mga teacher natin sa Philippines. Plus this kind of technology combined together, we will produce a very napakagaling ng mga engineers, mathematicians, and all professors. No? So sabi nga dito, no, ako nga, hindi na ako mathematics teacher, pero may mga napupulot ako mga dapat matandaan sa mathematics, like dun sa, kung kanina, sa Newton-Raphson na principle kanina, dapat yung may good value, dapat correct yung root, or else, ako, magugulo pala talaga at wala tayong makukuhang tamang sagot. Tapos, merong gusto ko yung mga imaginary na numbers, kapag yun, automatic, hindi sila tatanggapin, so hindi sila yung tamang sagot. And, in a limited time, Ma'am Red, Sir JD, limited time lang yun. Pero nakita natin, no, ganun pala kahusay talaga, ganun lang pala kadali with the use of this technology. Thank you very much, Engineer JD, for this, no. Maraming salamat. And, wala si Sir Joel, let's proceed to our guest commentator, Ma'am Red.
Yes. So, for like last week, for this session, we will be having someone as our guest commentator. So, parang third-party commentator siya. But she's also familiar with some of us because she also belongs to the pool of Casio Tech teachers. And currently, she is associated with Caloocan National Science and Technology High School as one of their teachers. So let's call Miss Mary Joy Villarreal. Joy?
Hello, Ma'am Mary Joy Villarreal.
Hello,
Hello po, Ate Joy.
Happy birthday. Yes,
Ayan, so, Ma'am Red, Engineer JD, meron lang tayong maririnig na words coming from Ma'am Mary Joy. Ma'am Mary Joy, please go ahead.
Ayan. So, first of all, I just want to commend this session, no? Kasi as a participant, talagang joiner talaga ako ng mga seminars. But I guess this is my first time to witness a session wherein the speaker, the trainer, is really an engineer. Kasi for me, I also have an experience before na nagturo ako ng pre-calculus sa STEM. So, since it's pilot year, share ko lang, parang, there's also a fear na parang baka hindi ko ma-discuss kasi ang STEM covered niya ang science, technology, engineering, and math. So what's good thing about this session is that I saw yung tinatawag na natin, sabi sa mga comments, hardcore problems. So Engineer JD was able to present problems that are not only content-based but it's context-based, culture-based. Kumbaga, may mga ginagamit siyang jargons ng engineers. And then, at the same time, field-based. Kasi para sa akin, no, very relevant to dahil nakikita natin kung ano ba yung mga problems na talagang kailangan din i-discuss ng teachers sa STEM, na nagtuturo ng mga STEM students who are trying to prepare their students to become engineers someday. Nakikita natin kung paano dapat yung approach because we observe in the presentation of Engineer JD na sabi ko nga parang hindi siya basta engineer, teacher na teacher talaga siya because he's using jargons of engineers but he was also able to translate it into some words na maintindihan kahit ng mga estudyante or teachers katulad ko na hindi naman masyadong exposed sa mga jargons ng engineers. So, this is very commendable and I want to congratulate also Sir Zayn for this first webinar with Casio. Thank you so much for sharing your expertise. Ate,
Yan. And with that, ito na ang ating boss at Big Casio Philippines na andito na Sir Joel to give us some words. Yes, Sir Joel.
Hi, good afternoon. Hello?
Yes, hello, Sir Joel. We can hear you.
Sorry medyo nawala yung signal kasi kanina. I'm having some difficulties right now. I'd like to congratulate Sir JD Lucero. So it was a very wonderful presentation. No? Even though hindi ako engineering guy, my attention was really caught by his presentation. Actually, it's called powerful presentation. And actually, yung aking anak dito, ay pinapanood ko yung presentation ni Sir JD. I told him yung discussion ni Sir JD, mapapakinabangan niya from STEM throughout hanggang mag-engineering course. No? I just don't know kung pipiliin niya yung CE. And it was interesting, no? Talagang yung especially from the very start, yung investigation ng pagguho ng building. I was really amazed.
Yeah.
Importante pala talaga yung tamang computation. Otherwise, guguho yung isang building or mali ang computation mo isang building or yung bridge, wala mangyayari sa construction kung halimbawa hindi ka talaga sanay gumawa ng ganong estimation or computation. So I like to say thank you very much Sir JD and hope to see you again in our future projects, no. And Sir Ma'am Reg, maraming salamat. Yung si Ma'am Joy, maraming salamat din for sharing your thoughts about this presentation. Alam mo Sir Ariel, may connection silang tatlo Napakaganda ng connection ng mga yan.
Yeah, tama to.
Silang tatlo mga scholars ng PINMA yan. And thank you PINMA for allowing us na for this presentation, mapahiram naman yung mga magagaling yung scholars sa amin. Si Sir JD, napanood ko yan nung unang Sir Ariel, si Sir JD is scholar ng Itbulaga pala. Tama, Sir JD?
Yeah.
Yes,
Tama po. Grabe top 1 sa ating word. Oh my goodness, 97 points.
Napanood ko yung Napanood ko yung episode na yun Pinapagibasa kanya si Joey De Leon. Ano project niya. Anyway, from my end, maraming salamat. Congratulations Sir JD. Saludo ako sa iyo. And I hope maraming bata na panood and maraming tutunan sa atin. Thank you. Definitely from Sir Mark Anthony, Sir Buddy, Sir Ariel, and the rest of the hardworking men and women ng DBTTU.
Any words, Sir JD, before we end our session for today?
Wala naman na siguro. Pero, yeah, I hope, marami silang natutunan today. At siguro, one way or another, kaya, ma-apply nila yung mga techniques ngayon sa design lang. They can also share, pwede nilang i-share sa mga friends nila, ng mga engineers, then mga STEM students. Pwede na kaya, alam ko to, napanood ko to sa ayun, at least makapagbigay tayo ng parang impact din sa mga students natin. Yan. So, I'm looking forward. Salamat sa opportunity na to. Actually, this is my first time and I'm looking forward. It may make mga kasunod na MATHtech sessions. And
So, yan.
If there are opportunities sa next math sessions, yan.
I think a lot of schools are watching and a lot of school heads are watching, and then get ready for the invite for JD. Malamang maraming sa'yo, the invite to talk about this kind of activity or this kind of topic. So makakatulong kasi talaga katulad nun, Sir Joel, sabi nga kanina, this is one of the best sessions yata ng Tech Day. Ito, natitest talaga kung gaano kalakas yung mga support ng buildings, yung mga talaga. This is highly recommended for all the STEM, napakagandang pag-aralan. Dami-dami ng ating mga discussion. Napakaganda. Gusto ko ako, PE major nga, sabi ko, pero kung naging interesado akong pag-aralan kung gaano kalakas o kung gaano yung katatag yung mga nilalagay ng mga material sa mga buildings. Yes, Ma'am Mary Joy. Mary Joy. Yes, Sir Joel.
Joy Villarreal.
Yes po. Ay, sige. Thank you po for the opportunity.
Yung isa sa mga video ni Ma'am Joy. Go ahead, Ma'am Joy.
Thank you po for the opportunity na mabigyan ko po ng comment yung session ni Sir Zaid. Saludo ako dyan. Saludo ako sa
Thank you.
Yun lang po.
Alright, thank you po.
Go, Sir, Ma'am Red.
Alright, so I think sobrang loaded ng information and learning at the same time yung araw na to mula sa session kanina ni Sir Quesada hanggang sa session ngayon ni Engineer Lucero. So I'm sure and natuwa yung mga participants natin. So again, teachers, learners, parents, guardians, engineering community, thank you so much for joining sa session natin ngayong araw and we hope to see you.
Thank you po.
Sessions. Tama ba, Sir Ariel?
Yes, okay. So tuloy-tuloy tayo na every Saturday we have this math day. So ito talagang pinagsama-sama natin ang lahat ng mga magagaling na speakers sa mathematics plus the number one technology in the country which is the Casio Education Philippines. Maraming salamat sa Casio Education Philippines.
Okay. Thank you, Sir Ariel. Sir JJ.
Okay, thank you. With that,
Thank you po.
Sir Joel, we'd like to invite din, mayroon tayong ilalabas ng mga posters regarding the video making contest about how do we use this calculator, this Casio calculator. So maglalabas tayo niyan. Just watch out. Stay tuned na sa ating mga announcements sa MATHtech na page. So we will be posting. May papremyo sa atin ang Team Casio Education Philippines. Maraming salamat. Okay, with that, thank you very much. Have a good day. Maraming salamat po. Shoutout sa SEO Las Piñas City. May shoutout pa kayo, Ma'am Red, Engineer JD, and Ma'am Joy. Baka may shoutout kayo.
Wala naman po.
So, with that, thank you very much. Have a good day.
Thank you po.
Thank you po. Thank you guys. Bye guys.